Good afternoon. My name is David Fries, and this is the BESA webinar. And today we're talking all things indoor air quality. But first up, a quick welcome to two new BESA members, BDAX and Aircon Scotland. Welcome to both companies. They've passed our more robust technical competence assessment standard. So congratulations to both of those companies and welcome to BESA. We'll be doing this more in future, but welcome to both of those companies. So today is about indoor air quality and how did BESA really get involved in indoor air quality? Well, some of you may recall that when we sold the office in Bayswater, we took up residence in Hammersmith for a short period of time and rented a couple of floors there. And we brought in some indoor air quality monitoring equipment as just an experiment. And what we found was that frequently we had spikes of PM10 and spikes of nitrogen dioxide that lasted for very short periods of time, less than a couple of minutes. And we were on the Cromwell Road, so we thought this is quite important to investigate, but couldn't understand why the spikes. So we didn't own the building, but we got permission and we had a look at the ventilation system and found that the air intake for the air handling units was actually at the point where the garage gate was, and cars were drawing up to the garage, idling, and the diesel fumes were getting directly drawn into the air handling unit and through the system. This was obvious to the maintenance company because they were continually changing the filters to such a degree that they actually took the decision the best thing they could do was remove the filters altogether, hence the spike. As we were in the building at the time and we were slightly concerned about the air that we breathed and the fairly arbitrary decision of the maintenance company to let us filter out the diesel particulate and the nitrogen dioxide, we decided to take a greater interest. So that's where we come into this big time. And I'd like to introduce Graeme Fox, who's head of technical, to introduce the new beginner's guide. Hello, Graeme.
Good afternoon, David. How are you?
I'm very well, thank you. You weren't party to that being successfully bunkered down in Dundee, but overrated chewing on diesel.
Yeah, I do remember having to open the windows to improve the air quality in Lincoln House. It was an interesting novel concept for the central London office.
Yeah, yes. And not too old a building either.
No.
Look, I'm going to let you get on, do the presentation. We'll come back with the panel for the Q&A.
Great stuff. Thank you, David. Okay, good afternoon, everyone. Thank you for joining us today. Big topic, indoor air quality, indoor environmental quality, common terms being used in conversations in diverse circles these days. But how many people actually understand what constitutes good or clean air? As building services engineers, we've understood for many years that we need to bring outside air into an occupied building like offices, shopping malls, etc. But with outdoor pollution levels sometimes being so poor, we can be exacerbating issues by drawing foul air into a building. And what about all the pollutants being created inside these buildings? This beginner's guide that we're launching today to indoor air quality is the result of several months of collaboration between members of the BESA Health and Wellbeing in Buildings Group Committee. In particular, I would like to thank Craig Booth, Fiona Lee and Sean Hill, driven on admirably by the group chair, Nathan Wood, and we'll be joined shortly by Nathan and Craig, and also with the support and input from the team at Mitsubishi Electric. So thanks very much for all the effort they've put into it as well. And we'll also be joined by Hern from Mitsubishi shortly. Also support from the British Lung Foundation and Global Action Plan. So it's got very good wide buy-in already, and our hope is that with this beginner's guide we can debunk this hot topic. So we're bombarded with good eating tips, advice on how much we should and shouldn't be drinking. More fruit, fewer carbs, more fiber, less alcohol, etc. Yet compared to the average 2 kilograms of food and 3 kilograms of fluid we take on into our bodies daily, we inhale around 13 kilograms of air every day. And that's when we're sedentary. If you're working out or involved in a more manual work, then the respiratory rate is obviously that much higher. And so therefore, the volume of air that we take into our lungs is that much higher. Poor air quality affects the oxygen levels, which in turn make us tired, less able to concentrate, irritable, more prone to infection. So it's essential that we address this issue in offices, schools and factories, but also in other public spaces like shopping malls, cinemas, restaurants, bars, etc. All places currently being looked at through the new prism of coronavirus contagion. MPs across the House, experts from all kinds of backgrounds, everybody is now seeing the importance of ventilation in addressing the COVID mitigation problem. But many aren't grasping that the reason good ventilation is a good mitigation measure is because good ventilation is an IAQ improvement measure across the board. Building services in general aren't noticed when they're working well. You don't generally sit in an office thinking, I'm very comfortable here, I wonder what air conditioning systems they use. When everything is working, you just don't notice it. It's only when you feel too hot or too cold, or there's a draft, or it starts to feel a bit stuffy, that suddenly you're thinking, this ventilation isn't working right, or this air conditioning system is rubbish. David often refers to the ventilation industry as a Cinderella trade, unseen and overlooked most of the time. And so this newfound attention the sector is getting has been very welcome indeed. But at the BESA, we've been investigating indoor air quality for years, as David just touched on. We've been looking at the correlation between poor indoor air quality and the outside conditions. One of the reasons our Health and Wellbeing in Buildings group was created in the first place. Trying to gain support for these concerns and raise awareness in the wider public arena has frequently been like hitting a brick wall. Lack of understanding, misunderstandings, too much technical terminology turning people off, and then it's a very hard sell. The BESA Health and Wellbeing in Buildings group have come together with Mitsubishi Electric to create this guide in an attempt to present the crucial facts in a non-technical language, so that everyone can get a grasp of the importance of the issue and take steps to improve the quality of the air in our buildings. Professionals with responsibility for facilities management of small to medium workplaces who may have no specialist knowledge of the subject matter. Building managers at schools and colleges can understand why and how they must make, or how they can make, I should say, incremental improvements to their indoor environments. And with so many people now working more from home, resulting in particulate matter building up in the home more readily now, you'll also start to pull together some tips for optimizing the indoor air quality in the home and understand the consequences, more importantly, of not doing so. It's estimated we spend around 90% of our time indoors in the UK. So to not look closely at the quality of air in the home could have catastrophic consequences on our family's health. Some common indoor pollutants, particulate matter, solids and liquids present in the air all around us, produced by cooking, cleaning, shedding of dust and fibres from clothing and furniture. Carbon dioxide built up by people exhaling, and even with low buildup of carbon dioxide, it can cause drowsiness and headaches and severely impact concentration levels. VOCs, volatile organic compounds, produced by aerosol sprays, cleaning products again, scented candles, printers and photocopiers in the office, among other things, again causing headaches and eye irritations. Humidity levels, too high and you may produce mold and fungus spores, causing allergic reactions and lung disease. Too low and you could be drying out your eyes, causing irritation, and possibly leaving your body more susceptible to infection due to lowering the ability to fend off respiratory attack. Better ventilation and treating the air that is in the building to improve the quality of the air we breathe can bring really tangible health benefits to the family and the nation as a whole. With a call to action at the end of this document to get people involved in the demands for better air quality, better ventilation, healthier public buildings, healthier school environments for our children, this beginner's guide to indoor air quality is exactly what the world has been waiting for to drive the issue forward and build momentum for a better, cleaner future. So why is there a problem and where are we going with all of this? Well, this is the definition of what constitutes acceptable indoor air quality according to BS ISO 16814 2008. You've got to love British standards. They're always a bit of a mouthful. I've read this definition several times and I'm still no clearer really as to what it even means in practical terms. It can be interpreted in such a wildly variant way as to mean very many different things to different people. Where the standard is useful, though, of course, is in its setting out of some of the parameters by which we need to measure good indoor air quality. Specifically, it sets out 3 methods by which you can express good indoor air quality. Firstly, by health, short term, such as irritation to the eyes or throat, as we've discussed, or longer term issues such as lung disease, cancers, asthma, etc. Secondly, by perceived air quality. So perceived air quality rather than acceptable indoor air quality is defined as where the majority of occupants express no dissatisfaction with the indoor air on the basis of odour or sensory irritation. Bit of a mouthful again. Or thirdly, by the ventilation rate. Now, from a design point of view, of course, it's normally the indirect ventilation rate method that is used because the designer can't know how susceptible the occupants will be to odours, etc. And the installation of sufficient ventilation by design will be seen as a measure of ensuring that the health measurement doesn't come into play. This is all fine for new builds or for major refurbishment works, but the vast majority of public buildings in use aren't new build, they're existing properties, frequently very old buildings that simply don't lend themselves to large ventilation systems or to centralised air handling units, for example. A number of schemes have popped up over the last year where the quality of air in a building has been measured and the building owner or manager is given a certificate with a clean bill of health for their property. In reality, that's about as much use as the car MOT certificate. It proves that at that date and at that time, the indoor air quality was okay. But what about the next day when 50 or 60 more people have come into that office? What about the next week after a commercial cleaning company has been in doing a deep clean? What about next month when the sun is shining and the school teachers open the windows wide open to let air into the classroom, but the traffic is building up again outside, so the outdoor pollution levels are rising? The only way to properly certify buildings is by introducing ongoing monitoring with reporting in real time to a common open source platform from which a certifying body can properly acknowledge the indoor air quality in that building is actually sufficient and crucially maintained. I've dubbed it BASH certification, buildings as safe havens, and we are reaching out currently to monitoring companies to work with us by providing API integration to an open platform from which we can certify the user has satisfactory indoor air quality in their public building. It has long-term benefits of ensuring buildings maintain good indoor air quality, and in the short term, it will give the public the confidence to re-enter public buildings post-pandemic, spending their money and kickstarting a starved economy again. This beginner's guide to indoor air quality is the first step to achieving that by raising awareness and a better understanding of the issues. And again, my thanks to the Health and Wellbeing in Buildings group at the BESA and of course Mitsubishi Electric for their efforts in helping produce this essential guide. And with that, I'm going to leave it at that because I'm hoping people are going to actually download the document, which is in the chat box in the meeting, and read it themselves. But for now, David, if you come back and introduce the rest of the panel.
Yep. Thank you very much, Graeme. Just to confirm, the guide is free.
Yes.
Okay,
sorry.
Thank you. So I'd like to welcome our panelists. That's Nathan Wood, who's Managing Director of Farmwood M&E. Craig Booth, who's Principal at Craig Booth Associates. And Hern Yao, Product Manager at Mitsubishi Electric. Welcome, gentlemen. I'm going to kick off, I think, with Craig Booth. Craig, what's the relationship between good indoor air quality and COVID-19? I think we've got to deal with the pandemic question first. So what's the relationship between the two?
Yeah, that's a great question because it is, of course, the great big elephant in the room right now is COVID-19, and it's been really good in a way. One of the byproducts of COVID-19 is that the attention towards indoor air quality, which was growing before the pandemic has really taken a massive boost, and that's because largely because good indoor air quality is in almost all respects the same as good COVID-19 biosecurity, by which I mean good ventilation to remove internally generated contaminants is absolutely key to COVID biosecurity, as it is to good health and well-being for occupants in non-pandemic times. Likewise, filtration, good quality filtration within the space is a significant contributor to reducing the potential for airborne viral load. And good filtration of outside air when you're drawing in more because you want to ventilate and dilute more is also key to reducing other unwanted contamination which might otherwise be introduced into the indoor space. So there's a very, very intimate connection. Good IA, good indoor air quality is good COVID biosecurity, I think.
Yeah, so I've been saying on this webinar for some time that throughout the pandemic, who knew ventilation was so important?
Yeah.
You know, before the pandemic, it was whatever that stuff is above the ceiling, do what you want with it, as long as I can see a nice fancy louver.
Yeah.
But now people are seeing, are you seeing that uptick in interest in not just ventilation, but good ventilation systems, Craig?
Yes, certainly. You see that during last summer in particular, as people were preparing for what was hoped to be the return to work in September, then there was intensive action to check ventilation systems to make sure that they were operating to maximum outdoor air ventilation levels, to make sure that things like fresh air intake pest guards, a particular bugbear of mine, but pest guards and frost protection batteries hadn't become clogged with dirt, quite simply, and so therefore the outdoor air makeup rates were certainly suboptimal. We did see a lot of that, and we still do, as people are in a sort of iterative way hoping to get back to the office, get back to work over the next few weeks now, I think.
So Nathan, as chair of the Indoor Air Quality and Wellbeing Group at BESA, is that what other members are telling you and what you're seeing?
Yeah, certainly. I think with the different backgrounds and companies and organisations that they work for, they're all coming together with a common voice, and that is the fact that it's been neglected for far too long, and suddenly everybody is asking them. I mean, anybody, any FM maintenance company, anybody involved in ventilation, but also the sustainability side of things as well. Suddenly, I think the sustainability people within organisations have been thrust forward, and health and safety as well in line with that. So the guide that we're talking about, and leading on to BASH, as Graham's just explained, is really important that people can understand the basics before we try to intervene with the complexities, and it is complex to deal with indoor air quality.
Yeah, I think BESA were unapologetic about how technically complicated and complex building services can be. You take shortcuts. It's easy to take shortcut solutions. Hern, a question for you. What's brought Mitsubishi Electric to help produce this guide with BESA, and what do you think is the next step?
Yeah, I mean, you know, the first and foremost is quite similar to what Craig and Nathan has already said. There's been such a boom in the demand for ventilation due to COVID, but what we have to be careful with is such a boom. It's so easy for people to get it wrong, like they say. You know, bringing it back to the basics to make sure that, you know, people going forward and putting in these systems in, checking that they're working, they are doing the right thing. and creating a better environment for themselves. You know, we've seen a lot of focus on outdoor air for the past, you know, probably decade, but people are still quite largely unaware of the harm that's, you know, even generated inside. So, you know, this thrusting of people becoming more involved with it. We need to take it back to basics and make sure everyone, you know, is brought up to the correct level of understanding. In terms of the next steps, you know, we are supporting BESA still, you know, looking at how we can lobby the government to get changes to the building regulations. You know, like you said with the BASH certification, you know, we'd like to see that, you know, where there's labels on buildings about the quality of the indoor air. So, you know, as you enter in to whatever space you're going into, whether it's, you know, public or even, you know, potentially your own home, you know, the quality of air you're getting is at an acceptable standard.
Okay, thank you. Graeme, I think you kind of answered this in your presentation, just some clarity. Are there any current UK or EU standards on indoor air quality?
Well, there is the British standard that I referred to in the slide. It's dated, I think, 2003 or 2008, although the British standards website does still say it's valid. I think it was reviewed just a few years ago, 3 or 4 years ago, so it is still valid. So that is the definitive standard, I guess.
Okay. Anybody got anything else on that before we move on?
Yeah, if I could.
Okay.
I think it's important to highlight as well that there's a lot of safe levels that aren't safe levels, depending on who you are, where you live, and your age, and lots of other different factors. And the WHO don't actually offer safe levels of exposure that BESA and EN do. So we need to be very conscious of that.
Is it safe to say, Craig, that actually the smaller, even smaller particulate matter is only just beginning to be researched and looked at, and we really don't know what the dangers are of that as it gets absorbed into the bloodstream and causing all kinds of other issues?
Yeah, I think absolutely. We're still. It is complicated because we're still working largely off work done at the back end of the last century and the beginning of this, leading up to the WHO Air Quality Report 2005, 15 years ago or 16 years ago already. And at that time, there was just a glimmer, an inkling that we ought to look at the particles smaller than PM 2.5, which is the usual smaller particles, PM10, the larger stuff, the stuff that tends to get stuck in your upper respiratory tract, PM 2.5, the smaller stuff, which tends to go deeper towards the depths of your lungs. But they were just starting then to get interested in the PM1. Which is more likely to go right the way through and direct into the bloodstream. So yeah, that is a developing area of interest. Yeah, that is indeed a true statement. Actually, I'd like to say something about the about standards. We do have a difficulty, and that difficulty is that the standards most people are naturally enough referring to are WHO 2005. But WHO 2005, certainly for particulate matter, was quite clear that there was no bottom level below which it was certain that healthy outcomes would ensue. They couldn't find that. In fact, they found that there was evidence of some adverse health effects, even down to or approaching background PM 2.5 levels of 2 and 3 milligrams per micrograms per cube. So the WHO, I think there's been a confusion in as much as the WHO 2005 work. It was avowedly the first step in an incremental process to reduce contamination levels over the long period, and which concentrated on areas of higher pollution. And really, you're thinking about sort of middle income countries, mega cities like sort of Mexico City, Guangdong, those sorts of things. And that sort of appreciation, looking at outdoor air, has kind of seeped into an idea of acceptability for indoor air, in the shelter, in the haven, which I think is a really bad mistake.
If I may.
Yeah, sure, Nathan. Then I'm going to follow up with.
Yeah, so already we're trying to keep things simple, and we've had background.
Sorry.
Yeah. That's why I chuckled a minute ago, we know this. This is what I'm saying. We understand this level, which is again bringing it back to the basics of the guide and the importance of that. But yeah.
So for people who are listening to this, who are practically working out, so what parameters can they measure to indicate an acceptable indoor air quality at the moment? What would you say they could use for that? Is there a table or a framework they can go to help them judge what is acceptable or good?
Sorry, I don't want to monopolise, but 16798, EN 16798 is very useful, because that describes various levels of supply air quality in terms of a percentage ratio to the WHO annual mean guidelines. So it says you're not doing too well if you're 1.5 times the WHO annual mean guidelines. You're doing okay if you're at the WHO guidelines, but you can get to 75%, 50%, 25% of those WHO guidelines. Then you're starting to really genuinely provide shelter, to providing good indoor air quality indoors. So yes, there are some pointers, but it up to now it's usually taken interpretation by what shall I say, experts or people familiar with the territory.
It is one of the biggest issues that we've got. We're trying to think about this, a BASH classification, for example, of buildings as safe havens. What do you actually define as safe? And we've had, within the working group, we've had a lot of discussion about this already. And the problem is, of course, yes, you can monitor for PM10, PM2.5, PM1. You can monitor for VOCs. You can monitor for all kinds of things, NOx. The problem is, the more things you're monitoring, the more expensive the monitoring kit's going to be.
Very much so.
And the more expensive the maintenance of that monitoring kit's going to be, and also the higher the potential for confusion as well within the general public. I think that's why a lot of people just take CO2 levels as being the very basic kind of indicative measure of what constitutes good air, and that would generally be, very good at 600 ppm, acceptable 800 ppm, borderline at 1000 ppm. That's the general measure.
When we talk about ppm, Graeme, if you work that into a relative percentage of what's in the air, you're talking a difference of 0.2% in the air of CO2 that can have a massive effect on your health and well-being.
Yeah, people really detect that. People really notice the difference between 600 ppm and 1000 ppm. When you walk into a building, you just get a nose for it, and the occupants do too. They go, it's not quite right. It's not quite. There's something a bit off. People are the best monitors in many respects. But sorry.
No, carry on, Craig. Sorry.
I was just talking about standards. It's happening much less now, but until quite recently, there was a terribly common misapprehension where people were saying, oh, well, my CO2 is under 5,000 ppm. The health and safety executive says it shouldn't exceed 5,000 ppm. Everything's fine, which was a massive misunderstanding of the standard set by the HSE for an occupational exposure. So this is like the drayman delivering the CO2 bottles in the cellar of the pub. No, he really mustn't see more than 5,000 ppm in a 15-minute period. As an occupational hazard, he has to deal with. But for non-occupational environmental exposure, they should be much lower than some of the standards which are knocking around and misunderstood. So we've got our work cut out to provide guidance here.
I'm going to spin my little bit about how we monitored air quality in a diesel submarine, which had the technology of Second World War. If you had a headache, CO2 was too high. If your cigarette wouldn't stay alight, there wasn't enough oxygen, so you needed to clean the air. But we do need the equivalent of a canary in the cage, isn't it? So at BESA we have food bots in the offices which just turn colour and just say, come and look at this because something's not quite right. Is that the kind of thing we should be advocating? Something, because accurate stuff is really expensive, isn't it?
Well, sorry, go on, Hern.
Yeah, I think we should be advocating that sort of stuff. Like you said, really accurate sensors is very expensive, and it's expensive to calibrate and maintain. But again, you know, I don't want to keep beating a drum. It's about awareness. You know, if you've got a cheaper sensor that's not reading potentially, you know, to the nearest 10 ppm, but at least you know that when you do an activity, it goes up. You know, and you can start to address that activity. So, you know, you could say you quickly monitor. A lot of these things are cloud-based now. You can see graphs plotted on time. If your VACs are going up every morning and struggling to get down, you know, by the time you get home, perhaps if you go to the office, then perhaps you're spraying deodorant or perfume in the morning in an unventilated room. You know, perhaps you should move that to, you know, just small behavioural changes you can do to affect it when you know what causes pollution. Something as simple as making sure you spray that deodorant in your bathroom with the extract fan on, or do it first thing in the morning if you don't have an extract fan and have the windows open until you leave the house and close them. You know, small things like that can make a big difference. So yeah, I think, you know, obviously, you know, being engineer based, very accurate sensors is something we'd like to see, but ultimately to make a big impact, you can start off quite small.
So I've got a couple of questions now related to schools, and I think everybody's aware that actually the damage to children's lungs is far worse than to adults because the lungs don't develop properly. The first one is my daughter's school is on a busy road, and they're having to leave windows open to the classroom for fresh air and diluting possible virus. The outside air, however, is clearly polluted by car fumes, but closing the windows increases the virus risk. What could I recommend to the school to do? And so how can and should I be sending my daughter to school? Is it safe? There's a follow-on to that, someone who's going to be working to help improve air qualities in schools. From your experience, what sort of things helped persuade head teachers, local councils and local businesses to take action? So the first bit is, how do I sort of reassure myself my kids are safe at school? And the second bit is, how do you inform head teachers, local councils, they need to do something about ventilation?
If I can jump in, I would say for the parent, engage with the school to start with. I think speak to them, find out what risk assessments they have in play. Have they done any monitoring of the outside air? There is no guarantee also that by opening a window that you will get convection in or out of that room. It is just that if the school hasn't got ventilation systems within them, it is the recommendation, keep doors or windows open. Again, there's no guarantee that traffic pollution will go into the building. There is a risk of it, as much as there is a risk of COVID coming in on one of the kids. So I think taking practical measures and speaking to the school, and practical measures being, if they can monitor the CO2, or if somebody has got a monitor. I mean, I'm sure if a school speaks to an air quality monitoring company, if they do some Googling, they will loan them one, because you know these air quality monitoring manufacturers are eager to get case studies and work with schools. But that said, also Global Action Plan and UNICEF have some really practical guides for how you can improve the basics of air quality in schools. But then to switch it, I mean, we've had quite a lot of involvement with schools ourselves, and we've got a nice program coming up with BESA that we're working on. The main angle I see is to work with the parent and teacher associations. They seem to have a lot of control and sway over decisions that are made. And quite often they have quite a few coppers sitting away in the purses on occasions, as we've found. So again, you need to be really careful about the advice that you seek and who you talk to. So there's lots of snake oil salesmen out there that are trying to sell all sorts of wonderful technologies. So it's really difficult to say do your research, because you probably won't know where to start. But certainly speak to BESA, contact BESA or the facilities managers of that building.
In Germany, they've said that they've got a program of improvements to mechanical ventilation. I think the Labour Party have also said there should be improvements to ventilation. Is that what you'd advocate, Craig?
I think ultimately we might have to. I was just going to say there that I think we have to draw a balance. There's always a balance to be drawn in everything. And at present, I think the acute risk associated with COVID is relatively high compared to the chronic risk associated with, let's say, nitrogen dioxide and particulate matter from traffic in a school. And I would choose to bring in more outdoor air to deal with the acute risk of COVID. And again, this idea of balance, I think that we're going to have to balance our sustainability and energy conservation desires with a desire for better ventilation, more warming up of cold outside air, and that is going to bring us towards more mechanical ventilation, I think. So I'm pretty confident that there will be more control offered to building occupants by means of mechanical ventilation as we go forward, to protect the occupants of the building against the outside, really, to provide the safe haven.
Hern, the natural ventilation's been used an awful lot in schools, and I think a lot of that was kind of predicated on the notion that natural outside air is somehow organic air, and the moment you stick it through a fan and a filter, it somehow becomes genetically modified air. Is that? Do you see that? There was a great rush to natural ventilation. Do you see that being reversed?
Yeah, I do actually. I think again, all the awareness around increasing ventilation rates because of COVID is kind of going to make it that way, because taking it back to BB 101, which is the standard for schools and their ventilation. It always bewildered me how if you were ventilating via natural means, you were allowed to target a higher CO2 level than mechanical, which to me just says natural ventilation, that standard says it's not as effective. So if you're taking into account future possible pandemics and things like we're in now, you need to guarantee air changes. And to me, the only way you could do that is through mechanical means.
Yeah.
Okay. Thank you. So Graeme, as an M&E service provider, the increase in awareness around the maintenance of ventilation systems is welcomed. However, until there is legislation that reflects that importance, we are all at the mercy of budget restrictions. What are BESA doing to raise awareness over the lack of legislation around indoor air quality?
Yeah, well, that's a very good question. What we can do about it, obviously, we talk to government bodies like BESA and MHCLG. There's the current building standards that are out for consultation. So Part F is on ventilation, and that does address a lot of the stuff like Hern's talking about making sure that buildings are future pandemics safe, if you like, or prepared, because it's talking about having additional ventilation in reserve, so that we do have the facility to increase ventilation next time something like this happens, because let's be honest, this won't be the last time we have a pandemic. We did find last year that when we first started to bring out the VGW2 guidance, for example, that we brought it last May, I think it was the first version of that, and we were talking about increasing ventilation at that time to 1.5 times, maybe 2 times what the current built standard is, which was 10 litres per second. We found that a lot of people come back and saying the trouble is that our ventilation system doesn't have that capacity in it. So it's quite heartening to see the consultation documents out that do talk about having 150% capacity. So that's what the kind of thing that we are trying to steer. Talking to other trade bodies, as I say, talking to government, civil servants, government ministers. This indoor air quality guide is being sent out to cross-party MPs and people in the House of Lords who have expressed an interest, either by making speeches or through social media approaches that they've done, talking about ventilation being important. So we've already done that. It's been anything with legislation changes. I think people who want to see change expect it and want it to happen quickly, and those of us that deal with civil servants understand that these things are frequently a combination of years spent banging your head off your desk or against a brick wall, responding to facetious responses and emails from people who all agree something must be done, but none of them will actually agree to help you do it. It's a long old process, but we are getting there. I think we are getting there. Again, it's about raising the awareness. We get the public awareness, we get that demand and that momentum going. It helps the legislators actually to come on board.
Of course, one piece of legislation that is coming down the pipeline in 2023 is the Building Safety Act. And that's going to seal buildings up to a greater degree than before for fire safety. Do we see any dangers in that, in sealing them, but actually treating ventilation in the same way? Who'd like to answer that one?
Well, there is, as always, a danger when you're sealing buildings up, that you're de facto, screwing up the ventilation rates. And one of the reasons we are where we are is because energy efficiency legislation for years has made buildings more airtight, which has, naturally reduced the ventilation within buildings. So that is something we need to address. And I've been talking to Hern and his team at Mitsubishi about that with heat recovery ventilation, so that you can actually increase the ventilation rates in buildings without losing that energy that you've put into it already.
So BESA has a very active ventilation hygiene group, and a question that relates to that. What impact does dirty ventilation ductwork systems have on the quality of air that passes through them? Craig, I'm going to ask you that one.
Well, it kind of adds a sort of extra layer of conditioning. I mean, I should just say the really topical thing at the moment is clogging and reduction of airflow at heat exchanger fins, at pest guards, and to a degree on some extract systems on extreme fouling, which is reducing the airflow by increasing resistance. But more generally, thinking about perhaps in many ways more importantly the supply duct systems, you provide a sort of extra conditioning of the air through the layer of dirt that has developed in the supply ductwork. So in the very worst cases, you'll smell it immediately. You'll just smell old dirt and associate that with a little extra humidity, and you'll have quite a potent odor. But more typically, of course, you're having very slight subliminal effects on the air passing through, which again, people are the best monitors. They detect that stuff. And then you have like the billiard ball effect, where the new particle coming in kicks off sometimes in a larger agglomerated set of particles, and you get the little smuts arriving in the served area.
I can also say there's been a lot of talk about using UVC treatment for air as part of the COVID mitigation. And actually, if you have a ducted supply and there's a lot of dirt and dust in that supply duct, it can seriously affect the efficacy of a UVC treatment piece of kit as well.
Okay.
Yeah, I'm sure.
So do we envisage getting to kind of clean room ISO standards for general workplace accommodation? Are we going to be getting to those standards?
I think somewhere in between,
Yeah.
you know, is where we should be aiming. Again, it's a cost issue, but I think the practicalities need to outweigh. Not outweigh. It is a case. I mean, practical measures like the barriers, putting the screens up on your desk, separating your spaces. Certainly, reactivating our office, we've gone through all the measures that we've needed to do. We've got a ventilation strategy. We've got mechanical ventilation heat recovery systems. But the strategy of where the inlets and outlets are don't work. You know, where I sit now, that used to be adequately ventilated in terms of recirculation of the air, not recirculation, but movement of the air through my path. If I have a CO2 monitor near me, it's moderate levels by 10 o'clock. You know, and I do like to talk, but you know, it's
and that's kind of touching on what I touched on in the presentation, isn't it? That it's all very well, but you can look at these things from a new build perspective, but most people are actually dealing with existing buildings and existing problems, exactly like you're highlighting, Nathan.
I think we do have something EN 16 or BS 16798 I referred to earlier, which certainly for particulate matter is providing comparison with WHO 100%. 75%, 50%. So in that way, we're getting towards the kind of levels of classification that we're familiar with in technical clean rooms, in microelectronic, pharmaceutical, etc. Production areas. So yes, I think that's what the standards setting that we need to do will extend from the clean rooms and bring us down into more ordinary environments, which don't need to be as clean as a clean room, but we can certainly aspire to move towards cleaner and cleaner indoor air and background level, approximating to background levels in a lovely environment. That's a thing that we should try and do, I think.
Yeah, I think we need to find somewhere in between, because a clinically clean room quite often, as everything enters that room, the tools, the equipment, it's sterilized. It's clean as it enters.
No, too much.
But in an office, there's so much more that generates pollutants inside. So it's nearly impossible to create that sort of environment in such a public space, if that makes sense. So there needs to be an in between for sure.
Yeah, that's my idea really of sort of extending downwards the clean room classifications, and at the very bottom of that classification would be the sort of almost sort of dirty town city centre air, would be right at the bottom of that continuum.
Okay. Next question. Building Regs approved document F is currently out for consultation, and that includes a big increase in fresh air ventilation for offices and commercial buildings. These proposals, direct result of the COVID pandemic. Does the panel have a view on the proposals? Should I start with Nathan?
As you said before, lots of systems won't be able to meet them. There's going to be lots of problems with noise as well when people are increasing their systems. A lot of the time they are balanced and commissioned and handed over. People move in, occupy offices, complain about the noise, a slight adjustment of a pot, speed regulator, and it's brought down, everyone's happy and everybody moves on. So ramping that up to meet these new levels, because people will try to meet the new guidance even if it's an older system, but the new ones going forward, it's people like at Mitsubishi and the other manufacturers that will have to step up to the plate and enhance their offering and bring forward new technology and ideas, efficient fans, efficient heat recovery cells, but also I believe that the manufacturers need to put more emphasis on the installer and the competent person who's putting them in. There's a lot more. Sorry to give you a bash in there, Hern, but yeah, step up.
So over to you, Hern.
No, I agree. I completely agree. You know, just increasing the fan speed when something's been designed at a lower rate, you know, it might be okay for a short period of time, you know, in the pandemic world we live in at the moment, where, you know, it's all taken us by surprise. But obviously, you know, the consultation part is trying to make sure we design that into buildings as a foolproof thing. And I think, yeah, there needs to be, you know, consideration into the noise and the comfort in those scenarios. You know, it can't, you know, I think first and foremost, the movement of the air is the most important. You know, that's what we need to achieve, but we need to make sure that we're not doing it in such a way that the occupants go, I'm not interested, you know, I can't think, you know, it just isn't practical to do so. So yeah, that's something obviously, you know, we need to take into account. And yeah, installer schemes, you know, and competent installers, again, it's kind of bringing it back to awareness again, isn't it? It's how important air is. And I use the term, you know, you need to respect the air. You know, it's not something soft and squishy that's so easy to move. You know, it's about creating that sort of awareness and best practice installation kind of schemes, essentially. Yeah.
The general feedback we've had from members so far on Part F has been positive in theory, but caution over the cost, because obviously, you know, increasing the ventilation rates by 50% is going to have a cost implication on build.
But I think our industry just needs to be ambitious. Needs to be say, yes, we're going to do that. We're going to improve the shelters that we're building for people. You know, I can't see that there's an alternative. I look at MVH, mechanical ventilation with heat recovery systems going into domestic dwelling units and flat blocks, and it's horrendous. We're building sort of vertical slums with horribly installed MVHR systems with 6 meters, 8 meters of flex ductwork squashed into inappropriate spaces, which means that that's certainly going to add to the noise. I mean, the poor old manufacturer of the MVHR fan system, he's going to get blamed for a noisy system, but you've got this horrible tortuous flex duct run, which is horribly noisy, and of course, you know, and yeah, that might well lead the occupant to switch off the MVHR as being noisy.
It's important to remember as well, of course, that increasing the ventilation rate doesn't necessarily mean actually increasing the ventilation equipment, because we're actually looking at a more flexible way of working and fewer people actually going into the office and things like that. If you have an office that was designed for 9 people and only 6 are going into it now, then you have actually increased that ventilation rate by 50%.
Yeah, the litres per second per person.
So you're achieving it. Yeah.
Okay, last couple of questions. What are your thoughts on UVC light disinfection for air quality as a standalone system? Craig, do you want to kick off on that one?
I'm concerned to find the to see the performance proof for in particular the dwell time. We've seen it very often with other treatment systems, that the dwell time, the amount of time that cube of air and the particulate and viral load contained within it, the amount of time that is exposed to the treatment is absolutely key, and it does very easily go wrong, that you get incomplete treatment. So I'm a little cautious until I've seen performance data.
I've seen some really good sorry, carry on, David.
No, carry on, Nathan, please.
I've seen some really good upper room germicidal results. The freestanding ones, if it's just a freestanding UV system on its own, I'm not that convinced. As part of a system with filters and UV, I think they get much better results. And again, there's the different wavelengths that the UV comes off, where the lamps are from. There's so much more to it than just saying UV.
We've also talked before, haven't we, Nathan, about being concerned about standalone units being stuck away in a corner, you know, and they're not going to be effective at all when you do that. So it's where it's located is critical as well.
As with everything in this industry, it's about taking out the shrink wrapped on a pallet and how you apply it, isn't it?
Yeah.
That's the application.
Too
So
right.
a final question that I'd like you all to answer, and I'm going to ask Graeme first, so he gets a head up. But this is a great question that's coming from a listener. Is working in the area of indoor air quality reserved for building services engineers due to its complexity? What opportunities are there for people with a keen interest to work more in this area who do not have an engineering degree? Graeme.
I don't think it's reserved just to engineers. I think if you have a practical mind and you have a genuine interest in the health side of it, and you understand the particulate side of it or the pollutant side of it, then I don't think it's reserved just to engineers. But I think you need to have an analytical mind to be able to understand the consequences of some of the engineering solutions that you might apply and how they will affect things. It's about having an ability to see the bigger picture. It's not just engineers, although we're best at it.
Nathan.
One thing our apprentices are really good at saying, and one thing that we push with them, is to say why. So I think somebody coming green as an apprentice is into the industry and just saying, well, why did you do that? Why is that? Why is that? That's probably the best thing. So I wouldn't say that you need an engineering background, as long as you're inquisitive and you ask the questions and don't necessarily accept the first answer from the first person that gives it to you.
Craig.
No, I don't think it is exclusive to building services engineers at all. I think what you will need is an understanding of how building services work, but they're not that complicated. Air comes in, air goes out, air is heated, air is filtered. Patterns of air inside spaces are not that difficult to get a handle on. So no, bring it on. Let's have a greater diversity. Let's break down the silos, I'd say. And
finally, Hern.
Yeah, I agree with everyone before. You know, you don't need an engineering background at all, because I think what's so good about the indoor air quality kind of industry is it's so vast. You know, you got different ways of doing it: natural, mechanical. You've got workplaces and homes. You know, if you're looking to make a difference, you can do that in so many different ways. It doesn't necessarily have to be, you know, designing a building or anything like that. You know, small behavioral patterns, making more people aware of what's around you in your homes, your relatives, your friends and families. You are making a difference. So, you know, I think anyone that's doing that sort of thing is contributing to the industry.
Yeah. I listened to Mark Carney, the ex-governor of the Bank of England, talking about the future of finance and particularly sustainability. And he said it doesn't matter where you are in an organization. You should be asking your employer, where is their plan for net zero? Where is their plan? Perhaps actually armed with this, just anybody could ask their employer, what is your plan for air in the office, school, where you're going? How are you ensuring that actually it's of an acceptable standard? So on that note, thank you all very much, Graeme, Nathan, Craig, Hern. As ever, we have a number of questions we just could not get round to. We'll put those up in our LinkedIn page, and the experts will answer them to the best of their ability. Join the discussion, join the debate. Coming up in the next few weeks, we've got that net zero carbon journey on the 19th of March. We've got great speakers from that. Mervyn Pilley from ESTA, who we are now in partnership with, Connor Storkey, Head of Sustainability at Mace, and Ian Fisher at Airmaster Air Conditioning. So make a date in your diary for that. As ever, if you've liked what you've heard, become a member. Join those companies we mentioned at the beginning of this webinar. they've joined for a reason. They see the value in membership, so please join us. And on that note, thank you to the panel. Thank you all very much, and we will see you again shortly.